Hello, welcome to day 3 of inverse trig functions. Today we're going to look at how we can use inverse trig functions to write an angle as a function of x. And this is pretty easy to do. If we take a look at our first example here, we're given two sides and our angle theta. So if I want to, just using the information they gave us the opposite side and the adjacent side. So we should know from geometry that this is our tangent, and that the tangent of the angle is going to be the opposite side, which is x, over the adjacent side, which is 8. Now, if I want to solve for x, that's pretty easy. X would equal 8 times the tangent of theta, and that would be pretty easy. But that's not what they're asking us to do. They want us to write theta as a function of x. So that's not going to be our answer here. In order to do this, again, it's very simple. We're going to use inverse trigs. Because remember, in inverse trig, this theta is my angle. This is my value. Inverse trig says I'm just going to switch them around. So I take the inverse tangent of x over 8, and that's going to equal theta. And there's your answer. Very easy to do. So if we take a look at example number 2, same idea. They gave me the opposite side, and the x is my hypotenuse. So which trig function has the opposite and the hypotenuse? Of course, it's going to be the sine. So the sine of our angle is the opposite over x. Now, we need to solve for theta. So in order to solve for theta, we're just going to switch them. That's what an inverse does. That's an inverse. I'm just going to switch them. And this becomes the inverse sine of 5 over x equals theta. And there's our answer. And we're going to use this tomorrow to be able to use calculators to find out trig values, to find values or angles for trig. Anyway, so. Now, we do have a few properties for inverse trig that are pretty easy to work with. And basically what it says, if we're within our domain, remember sine is inverse sine goes from negative pi over 2 to pi over 2. Cosine goes from 0 to pi. And, of course, tangent, again, from negative to infinity. So if we just follow our domain, it's pretty easy to do. Arc, sine, and sine, these are inverses. So basically what they're saying is inverses cancel each other out. It's the same idea as if I take the square root of x and I square it. These are inverse functions, so what do we get? X, provided x is positive, of course. Same thing here. Sine and arc sine are inverses, so what should I get? 0.6. Tangent of 35, tangent of the arc, tangent of 35, again, inverses. So we should just get 35. And that's one of the most basic properties that we have. Okay? Very easy to do. And you can follow your notes and kind of hopefully follow along with that. All right. Taking a look in the back, we want to write an algebraic expression that is equivalent to the given expression. We've already done this before. This was yesterday's assignment. We will have the sine of the arc tangent of x. So we're looking for the value. This is the one where we have to draw our right triangle. So this is the arc tangent of x, which means that is my opposite side, and they don't give it to you directly, but we know that the adjacent side is 1, because that's going to be over 1. So if I draw out my right triangle, just like we did yesterday, my opposite side is x, my adjacent is 1, there's theta, and Pythagorean theorem, this is going to be x squared plus 1, and the square root of that. And if you need to, remember it's x squared plus 1 equals c squared. Oh, look, c is the square root of x squared plus 1. So if I want to get the sine of that angle then, the sine of theta is going to be the opposite over the hypotenuse, x squared plus 1. Very easy to do. Now let's try the next one. Secant of the arctangent. Don't forget, put a 1 under there if you need to. There's my opposite, OPP, you know me, and there's our adjacent side. So that's not looking adjacent, our adjacent side. So drawing a right triangle, there's theta. My opposite is 3x, there's my adjacent. So using my Pythagorean theorem, this becomes 9x squared plus 1, because 1 squared is 1. And now I want the secant of theta. And nobody knows the secant of theta, but we do know it's the flip of cosine of theta. So if I get the secant of theta, if I get the cosine of theta, it's very easy. It's the adjacent over the hypotenuse. And I flip it. Therefore, the secant of theta is just the square root of 9x squared plus 1. Very easy to do. All right, let's try number 3 and 4 here, and then we'll be done. All right, so, oh, look, the cotangent of the arc cosine. So, take a look here. Cosine, this is my cosine function, right? So, this is going to be, maybe it's my arc cosine, so these are my values. Okay, so this is going to be the adjacent, and this 3 is the hypotenuse. So we're looking for the value. We can get the angle here. So using your right triangle, there's theta. The adjacent is x. The hypotenuse is 3. Be careful this time. This time we get the square root of 9 minus x squared. Be very careful with that one. So to get the cotangent of that angle, now nobody knows cotangent, but we do know tangent. And tangent's pretty easy to do. Tangent of theta is the opposite, the square root of 9 minus x squared over the adjacent x. Therefore, the cotangent is going to be flipped that. X over the square root of 9 minus x squared. And there's our cotangent of our angle. All right. Number 4. The arc sine, remember, there's a 1 underneath there if you need to. Helps me draw my triangle. The top, that's my opposite. The bottom is my hypotenuse. So if we sketch this out, this is a little bit trickier. Okay, if I sketch that out, there's my right angle, there's theta. The opposite is x minus 1, the hypotenuse is 1. So when I do this, be very careful. Don't be fancy. It's just x plus minus 1 squared plus b squared equals c squared. So b squared equals 1 minus x minus 1 squared. Solve for b. I get the square root of 1 minus x minus 1 squared. Don't be a hero and try to simplify that. This is perfectly okay to use. 1 minus x minus 1 squared. And now I want the secant. Now again, nobody knows secant of theta, but again it's 1 over the cosine of theta. And we do know cosine of theta is the adjacent, the square root of 1 minus x minus 1 squared over the hypotenuse 1. So that gives us our secant of our angle being 1 over all of that jazz. 1 minus x minus 1 squared. And there is our answer. All right. We'll practice some more of these tomorrow in class, and I'll see you then. Bye-bye.